Imagine an expert confidently delivering facts, only for those facts to be completely made up. This unsettling phenomenon is precisely what we observe in large language models, often termed hallucination. It's not a glitch in the traditional sense, but a fundamental characteristic of how these powerful AIs operate. Researchers describe it as the model generating content that is nonsensical or untrue relative to the real world, yet presented with the same persuasive tone as accurate information. Understanding this is crucial, especially as LLMs become integrated into critical applications, where a confident lie can have significant consequences. Before we probe why LLMs hallucinate, let's establish what they are. At their core, large language models are sophisticated neural networks, trained on colossal datasets of text and code. According to OpenAI's foundational explanations, these models learn to predict the next word, or token, in a sequence based on the preceding context. They don't understand in a human sense. Instead, they discern statistical relationships and patterns across billions of data points. This predictive nature is key to both their incredible capabilities and their puzzling propensity to fabricate. The foundation of any LLM is its training data, vast corpora of text scraped from the internet, books, articles, and more. Reports from leading AI labs, like DeepMind and Meta, indicate these datasets can encompass trillions of words. The quality and veracity of this input are paramount. If the training data contains errors, biases, or contradictory information, the model has no way to distinguish truth from falsehood. It simply learns to replicate the statistical patterns present in the data, regardless of their real-world accuracy. This forms the first significant vulnerability to hallucination. Experts at Google AI emphasize that LLMs are, fundamentally, statistical pattern matching machines. They excel at identifying the most probable sequence of words that follows a given prompt. When an LLM generates text, it's not recalling facts from a knowledge base in a conscious manner, it's completing a complex autocomplete task. This process, while incredibly powerful for generating coherent and contextually relevant text, offers no inherent guarantee of factual accuracy. The model optimizes for fluency and plausibility, not truth. If a false statement appears frequently or plausibly in its training data, it may reproduce it. What exactly do researchers mean by hallucination? According to a 2023 study published in Nature Machine Intelligence, it's formally defined as the generation of content that is factually incorrect, nonsensical, or unfaithful to the provided source content, while being presented as if it were true. This definition highlights two main types: intrinsic hallucination, where the output contradicts the source material, and extrinsic hallucination, where the output diverges from the source without contradiction but introduces new, incorrect information. Both undermine user trust and the utility of LLMs. One primary driver of hallucination is data contamination. As reported by researchers at Stanford, even meticulously curated datasets can contain erroneous information, factual inaccuracies, or outdated claims. LLMs don't have an internal fact-checker. If a piece of misinformation is prevalent in the training data, the model learns to reproduce it. Consider how much unverified content exists on the internet, a primary source for training data. When an LLM encounters such data, it treats it as equally valid input, leading to outputs that appear confident but are factually baseless. Another significant factor, particularly for models like GPT 3.5 or Claude, is the knowledge cutoff. These models are trained up to a certain date, and any events or information occurring after that point are simply not part of their world. When asked about recent events, the model, rather than admitting ignorance, will often confabulate, constructing plausible-sounding answers based on its existing, but outdated, knowledge patterns. As technologists at Google have highlighted, this isn't malice, but a limitation of their static training dataset, forcing them to guess where information is absent. Confabulation is a core aspect of LLM hallucination. It refers to the model's tendency to create vivid, but false, memories or explanations to fill gaps in its knowledge, much like a human suffering from certain neurological conditions. A study by IBM researchers describes this as the model making up information that sounds contextually appropriate, even if it's completely fabricated. This isn't an intentional deception, the model is simply optimized to produce coherent text. If it doesn't know the answer, it generates the most statistically probable string of words that looks like an answer. A critical insight from neurolinguistic programming and AI alignment researchers is that LLMs lack a true world model. They don't possess an internal representation of how the world works, or fundamental common sense. When we ask, "Can a tree swim?" we understand the physical properties involved. An LLM, however, merely processes words like tree and swim based on their statistical co-occurrence in its training data. If tree and swim rarely appear together in a logical context, it might try to force a connection or generate an absurd scenario, lacking any real understanding of physical laws. The vastness of the internet means that even for well-established facts, conflicting information can exist. A recent report by MIT Center for Advanced Virtuality highlighted how different sources might present slightly varied or even contradictory accounts of the same event. When an LLM is trained on this divergent data, it learns multiple, sometimes opposing, statistical patterns. When prompted, it might randomly select one of these patterns or attempt to synthesize them, leading to an output that is a blend of truths and falsehoods, or simply one confidently asserted but incorrect version. LLMs are designed to be conversational and helpful, always aiming to provide an answer. This inherent pressure to respond, as some cognitive scientists specializing in AI describe it, can exacerbate hallucination. Rather than stating "I don't know," which would break the conversational flow, the model defaults to generating a plausible response, even if its confidence in the factual accuracy is low. It prioritizes completing the sentence fluently over factual precision, especially when the prompt is vague or falls into a less represented area of its training data. The process of generating text from an LLM involves sophisticated algorithms like beam search or sampling. As explained by NVIDIA's deep learning researchers, beam search explores multiple potential next words to build the most probable sequence, while sampling introduces an element of randomness, controlled by a temperature parameter. A higher temperature makes the output more creative but also more prone to hallucination, as it encourages less probable, but perhaps more novel, token choices. This delicate balance between creativity and factual adherence is a constant tuning challenge. The way a user phrases their query, known as prompt engineering, can significantly influence whether an LLM hallucinates. Research from leading AI consultancy, Anthropic, demonstrates that vague, ambiguous, or leading prompts can push the model towards generating imaginative rather than factual responses. If a user asks a question with an implied false premise, the model, in its effort to be helpful, might follow that premise. Precise, clear, and well-structured prompts, conversely, tend to elicit more accurate and less hallucinatory outputs by narrowing the scope of the model's search space. Unlike humans, LLMs don't truly know where their information comes from. They merely process statistical relationships between tokens. When asked to cite sources, as observed in studies by Cornell University's AI ethics group, models often generate plausible-looking but entirely fabricated references, complete with non-existent authors, publications, and page numbers. This inability to accurately attribute information is a direct consequence of their training methodology and the absence of a symbolic, verifiable knowledge graph. They predict what a citation should look like, rather than recalling an actual one. The phenomenon of hallucination carries significant ethical implications. As noted by the European Commission's AI Act proposals, reliance on LLMs for critical tasks like legal advice, medical diagnoses, or journalistic reporting without robust fact-checking can lead to serious harm. Misinformation generated by AI, even if unintentional, can spread rapidly, eroding public trust in both AI systems and factual information in general. The challenge is balancing the incredible utility and creativity of LLMs with the imperative for accuracy and accountability. researchers are actively developing strategies to curb hallucination. One of the most promising is retrieval augmented generation, or RAG. As pioneered by Facebook AI Research, FAIR, RAG combines the generative power of an LLM with an external, verifiable knowledge base. Before generating a response, the system first retrieves relevant documents from this reliable source and then uses that retrieved information to inform its answer. This provides the model with a ground truth to reference, significantly reducing its tendency to confabulate and improving factual accuracy. Another crucial mitigation strategy, often deployed in conjunction with RAG, is automated and human-in-the-loop fact-checking. Companies like OpenAI are integrating internal fact-checking mechanisms, where the LLM's output is cross-referenced against multiple reputable sources before being presented to the user. For high-stakes applications, human oversight remains indispensable. Experts at NIST advocate for clear human verification steps, where AI-generated content is reviewed and validated by human experts, especially in fields where accuracy is paramount, such as scientific research or financial reporting. Improving the quality of training data is a continuous effort. Organizations like Hugging Face are emphasizing rigorous data curation, involving careful filtering of low-quality or potentially misleading information, and augmenting datasets with high-quality, verified factual sources. This includes techniques to identify and remove contradictions, biases, and outdated facts directly from the training pipeline. While a massive undertaking, investing in cleaner, more reliable data fundamentally strengthens the LLM's factual grounding and reduces the garbage in, garbage out problem at its source. Fine-tuning and instruction following are also proving effective. After initial broad training, models can be fine-tuned on specific, high-quality datasets to improve performance in particular domains. Furthermore, researchers at Google have shown that explicitly training models to follow instructions like "do not make up facts" or "only use provided sources" can significantly reduce hallucination rates. This involves reinforcement learning with human feedback, RLHF, where human evaluators guide the model towards less hallucinatory behavior through iterative feedback loops, essentially teaching it to be more honest. Beyond data and training methods, advancements in model architecture itself are being explored. New architectures are designed to incorporate mechanisms that inherently promote factual consistency. For instance, some experimental models are being developed with separate knowledge modules that can be explicitly queried, rather than relying solely on the general predictive engine. While still in early research phases, this could lead to LLMs that are not only powerful generators of text but also more reliable repositories of verifiable information, according to papers published by Microsoft Research. Despite these impressive mitigation strategies, eliminating hallucination entirely remains an ongoing, complex challenge. As stated by AI ethicists from the Allen Institute for AI, it's not a bug to be patched, but a fundamental property of how current generative models operate. The goal isn't necessarily to achieve 100% factual accuracy in every context, which might be an impossible standard even for humans, but to reduce the frequency and severity of hallucinations, especially in high-stakes domains. The AI community acknowledges this as a central hurdle for broader, safer AI adoption. So, LLMs hallucinate because they are statistical engines, trained on imperfect data, optimizing for plausible text rather than absolute truth, and lacking a genuine understanding of the world. They are powerful tools, but they are not infallible oracles. As we've investigated, the solutions involve a multi-pronged approach: better data, smarter architectures, external knowledge bases, and diligent human oversight. For users, the takeaway is clear: critical thinking remains paramount. Verify, question, and use AI as an assistant, not an ultimate authority. The journey to more reliable AI is well underway, and your informed use is a crucial part of that progress.